we've now got a working definition of what a microservice is. Now, at the end of the last video, we were looking at this diagram right here, and when you were looking at this, you might have said to yourself, oh, okay, microservices are easy. All we have to do is take a feature, wrap it in a service, and that's it. Well, unfortunately, reality is just a little bit different. It turns out that when we start working with microservices, there are some really big challenges that we start to run into. So in this video, I want to start to introduce one of these really big challenges. So here's what it is. Data management between services. When I say data management, I'm talking about the way in which we store data inside of a service and how we communicate that data between different services. Let me take a pause right here and just tell you flat out, this is a very big, very challenging problem. It is a huge obstacle to effectively using microservices. The good news is that this problem right here is what we are going to have an unending focus on in this course. And by the end of this course, you're going to have a couple of different strategies for working with this data management problem. So now let me tell you a little bit more about why this is a problem. Let me help you understand why this is such a big thing. Okay, so a little bit of preamble here, a little bit of background. With microservices, the way in which we store data and access data is a little bit weird. And what I mean by weird is that it's just a little bit different than what you might be used to with a monolithic application. So in the next couple of diagrams, we're going to take a look at how we store data and how we access data in a microservices approach. So first off, how do we store data in a microservices system? We might recall the diagram we were looking at just a moment ago. I showed a separate database for every service that we had created. So whenever we are making use of microservices, we are going to create a separate database for each service, if the service actually needs a database. If a service doesn't need a database, that's fine. We're not going to give it one. But the point is, every service gets its own database. Now that might sound really strange, but I'm going to give you a very good reason for this in just a moment. First, let me also show you how we access data. And once again, this is going to be a little bit strange. So to access data, I'm not going to tell you exactly how we're going to access data. I'm going to tell you how we are not going to access data. So we are never going to access data by reaching from one service into another service's database. So under no circumstance will we ever have service A right here try to reach into the database for service B. And once again, I'm going to give you a very good reason for this in just a moment. Okay, so in total, here are the two big kind of surprising facts that I've now mentioned. First off, each service is going to get its own database if it needs one. And secondly, services are never going to reach into another service's database. So now let me tell you why this is. Why are we doing this? Because these seem like two very strange rules. There's a couple of different reasons. First, I want you to understand that this whole idea of giving every service its own database is known as a pattern. The pattern is called database per service. So as you'd expect, that just means every service has its own database. But here are a couple of reasons, and this is by no means an exhaustive list. The first reason, and this is the really big reason, is that we want every service we create to run independently of other services. So let me show you a quick diagram to help you understand why giving each service its own database is going to help with that. All right, so first, let's imagine a scenario where we have every service using the same common database. So maybe it's just one database right here. We'll call it database for everything. The problem with this approach is that if anything bad ever happens to this database, all of our services are going to crash immediately. The other big problem is that scaling this database right here would be really challenging. If every service inside of our application uses the same database, we're going to have to scale up that one database instance or that one database to service all the different services of our app. It would be a lot easier to scale just the databases that need additional capacity or throughput. The other scenario that we could run in, let's imagine that we've got service A reaching out to database B's service right here. If anything ever goes wrong with database B right there, then all of a sudden, service A is going to start to crash because we have introduced a dependency between service A and service B. So if a request comes into service A and feature A tries to reach over to this database and something is wrong with that database, boom, service A is going to crash as well. And so rather than just losing service B, we would now also be losing service A. So by giving each service its own database and making sure that each service only uses its own database, we dramatically increase the uptime of our entire system. Now, next reason, let's see right here. So next reason that we have this database per service pattern is that the schema or structure of a database might change unexpectedly. So a quick example of this as well. I want you to imagine for a second that we've got service A reaching directly over to database B over here. And again, this is not what we want. I'm giving you an example of why we do not do this. So let's imagine that feature A usually runs a query of something like get user inside of B. And usually, database B returns an object that has a name of Jill or something like that. Whatever the name is, the point is that it's got a key of name right there. Now let's imagine that for some reason, service B, the team that is in charge of it, decides to change the schema or the structure of this database. And maybe they decide that rather than giving every user a name property, maybe they want to call that first name instead. Let's further imagine that maybe the team in charge of service B does not tell the team in charge of service A about the change to the schema right here. If that were to happen, then the next time that service A makes a query down here, they're going to get back an object that has a first name property instead of name. Service A was probably not configured to expect to see a property of first name, and so now we might start to have some issues start to arise in service A, all because we tried to rely upon a database located in a different service, and that second database right there had its structure or schema change at some point in time. Now, the last reason I'm going to throw out here really quickly is that some services might be able to function more efficiently if they are using a different type of database. So for example, maybe one service can run more efficiently if it uses Mongo or MongoDB as opposed to Postgres or something similar to that. This whole database per service pattern might seem a little bit surprising, and you might already be saying, Stephen, there's no way this is how it's done. There's no way we're creating a separate database for every service. Well, this is reality. This is how every successful engineering team out there is using microservices. They are all, every last one of them, following this pattern right here. One database per service. Okay, so now that we've set up this kind of weird pattern right here, we still have not really touched on why data management between services is really challenging. So quick pause right here. We're going to come back in the next video and start to expand on this in just a moment.